Extinction is a fact of life on Earth. Our planet is always changing, and not every species can handle the changes. So it's pretty normal for a handful of species to go extinct every year. But sometimes, huge changes cause lots of extinction, and tons of species disappear in a relatively short time all over the world. A mass extinction. These events are terrifying and fascinating. By studying mass extinctions, we learn how our world got the way it is now, and where it's headed. Right now, rates of extinction are so high that we might be on the verge of a modern mass extinction. Experts predict that if this trend continues, we could lose up to 50% of all species on Earth by 2050. So, for this video series, I'm partnering with Colossal, ding, the de-extinction company working to prevent the next mass extinction. Throughout Earth's history, there have been 5 famous mass extinction events, the Big Five. In each one, more than 70% of life on Earth died out. In this series, we're going to explore the causes and effects of each of them, one by one, to lay out what we know about mass extinctions of the past, so we can prevent another one. First up is the oldest of the Big Five, the Ordovician Mass Extinction. The Ordovician period was from 485 to 444 million years ago. During this time, the Earth was like an alien world. There were no familiar shapes among the continents or oceans. Most of the land masses were in the southern hemisphere, like the supercontinent Gondwana. The world was very warm and had very high sea levels, which created lots of warm, shallow ocean habitats. Those warm oceans are where we find Ordovician life, like Eurypterid sea scorpions crawling along the ocean floor. Some of them got to almost 6 feet long. Squid-like cephalopods with massive shells drifted through the water. The biggest ones, like Endoceras, were almost 20 feet long. I like those cones a lot. There were ancient corals, sea lilies, sponges, lamp shells, etc. This was also the time of the trilobites. Big ones, small ones, spiky and smooth, crawling and swimming and burrowing all over the ocean. There were also fish too. They were strange, jawless species, including eel-like conodonts, and also ones like Sacabambaspis, a tiny jawless fish that had armored plates on their heads. Almost all life at this time lived in the water. The land was almost completely barren, except for some of the earliest land plants that were just starting to creep up. Fossil spores provide evidence that simple non-vascular plants, similar to like mosses and liverworts, forming green carpets over the rocks, very mid-century. At the end of the Ordovician, in the last 2 million years or so of the period, this alien world was rocked by a global mass extinction. In the fossil record, we see about 85% of species disappear. Trilobites, corals, fishes, every group experienced major loss. This is the first time that animal life on Earth experienced a global collapse of this scale, that we know of. But a mass extinction doesn't happen for no reason. Rocks and fossils from the late Ordovician contain clues to the cause of this catastrophe. Specifically, changes in the chemical makeup of certain minerals reflect a massive climate fluctuation. First, the Earth got slapped with a global cooling, and then slapped with a global warming, a 1-2 punch of destruction. It starts with an event called the Hernantian glaciation, the Ordovician Ice Age. Scientists have identified geologic evidence of ice sheets at the South Pole, kind of like the ice that covers Antarctica today. Also, a drop in sea level of about 300 feet. All that water was frozen into ice. Global temperatures dropped at least 5 degrees Celsius, disrupting the formation of certain minerals and leaving telltale evidence in rocks and fossils. All of this was bad for sea life. Colder temperatures were a big problem for any species that got very cozy in those warm waters. And also, as sea levels fell, the water drained away from coastlines and shallow seas, so their habitats were donezo anyway. Changes to sea level and water temperature also disrupt ocean chemistry and circulation, which can mess with animal migrations, reproduction, even down to the basic finding food and breathing properly. But an ice age doesn't happen for no reason either. The cause of the cooling was a change in the atmosphere. Minerals from the late Ordovician period show a change in their carbon composition, the kind of change that happens when atmosphere is running low on carbon dioxide. Carbon dioxide is a greenhouse gas, which means it traps heat in the atmosphere. Less CO2 in the air means less trapped heat, means cooler global climate. Exactly why CO2 levels plummeted in the late Ordovician is hard to say for sure, but there are 2 prime suspects that were suspiciously active at this time in Earth's history: volcanoes and plants. Volcanoes are where baby rocks come from. As the lava cools, it forms new solid rock. And if that rock is exposed to the air, it can experience chemical weathering, which is a process that pulls CO2 out of the atmosphere. Lava rocks from the late Ordovician provide evidence that volcanoes were erupting at that time, producing lots of new rocks that were weathering away. But you know what else draws CO2 out of the air? Yeah, plants. Like I said before, land plants were just getting started in the Ordovician. Just like we breathe in oxygen to fuel our bodies, plants breathe in carbon dioxide to power their photosynthesis. As plants became more common on lands, they pulled more and more carbon dioxide from the atmosphere. Land plants also churn up the ground, pulling up mineral nutrients that end up getting washed into the oceans. Similar nutrients can also be released from volcanic eruptions and from weathering rocks. As those nutrients concentrate in shallow waters, they can become fuel for massive blooms of algae, cyanobacteria, which also suck up carbon dioxide. So, Some combination of land plants, volcanoes, and algal blooms was pulling lots of carbon out of the Ordovician atmosphere. And once the cooling trend got started, it snowballed. As water freezes into ice, sea levels drop, which exposes more land to weathering, which draws down more CO2, which means more cooling, and on, and on, and on. Ice is also very reflective, so sunlight bounces off of it, taking some heat with it. In the late Ordovician, the giant continent Gondwana sat right over the South Pole, so there was lots of room for massive ice sheets. As the ice sheets grew, they reflected more and more heat, and the air got colder, and on, and on, and on. Freezing water also acts as a trap for carbon dioxide. Rain pulls carbon dioxide down with it. When the water freezes, the CO2 gets stuck in the ice. This is called a positive feedback loop, a series of events that reinforce themselves. But if you were to ask the Ordovician species, they'd say it was very negative for them. Some species were pretty quick to adapt to the changing climate. Certain late Ordovician fossil sites are full of cold-adapted species that established new ecosystems in these cooler conditions. But then, the second slept. Right before the end of the Ordovician, the Ice Age ended. All those trends we see in the rocks and fossils become reversed, reflecting new trends of rising temperatures, rising sea levels, and rising carbon dioxide in the atmosphere. Ocean habitats got messed up again. Those cold adapted ecosystems that had literally just settled were destroyed by warming temperatures. And once again, there were global changes to ocean chemistry and circulation, as well as the shape of shallow ocean habitats. Rising temperatures and CO2 in the ocean can also lead to ocean acidification, a change in seawater chemistry that dissolves the shells and skeletons of species like corals and plankton, which form the foundation of ocean ecosystems. The rock record of the latest Ordovician also contains deposits of black shale, a type of rock that forms from sediment deposited in oxygen-poor water. Ocean circulation is responsible for carrying oxygen from the atmosphere down to deeper waters. When that circulation changes, certain waters can become deprived of oxygen. Also, when those massive blooms of algae die, they decompose, which is a chemical process that sucks up oxygen from the water. So, between changing circulation patterns and lots of decomposing microbes, oxygen levels were dropping all over the ocean, suffocating marine life and leaving behind those black shales. And just like ice ages don't start for no reason, they also don't end for no reason. In this case, the reason is most likely those volcanoes. I said before that volcanoes can lead to cooling, which is true, especially on short time scales. But volcanic gases also contain lots of carbon dioxide. So when volcanic eruptions continue for a long time, they release tons of CO2 into the atmosphere. Then we get those runaway processes again, in reverse. More CO2 traps more heat, so the climate gets warmer. Warmer temperatures melt more ice, which reflects less heat, releases trapped carbon dioxide, leading to more warming. Melting ice also floods the seas, raising sea levels, flooding exposed to land, protecting the rocks from weathering, so less CO2 is being pulled out of the air, and so on, and so on, and so on. And before you know it, the ice age is over, the world is warm again, and ecosystems are in shambles. By the time it's all done, about 443 million years ago, most of that alien Ordovician biodiversity is gone. About 85% of species became extinct. Some of the hardest hit groups were temperature-sensitive species like corals, sponges, and plankton. And so many other species rely on these animals for food and shelter that with them gone, entire ecosystems collapsed. Some groups eventually recover pretty well. Sea lilies and fish go on to become highly diverse and successful again. Other groups never regain their former glory. Trilobites got hit pretty hard, and they're never again as widespread or varied as they were in the Ordovician. And some groups vanished completely, like those giant Endocerus cephalopods. And in case you're wondering, land plants were fine. They were pretty much barely affected. They're probably responsible for this whole fiasco, but it's everyone else that suffered for it, as that's just the way it works. But life on Earth goes on. After the Ordovician comes the Silurian period. Recovery starts off slow, but gradually plants and animals develop all new ecosystems throughout the seas, and eventually on land too. And soon the world is once again home to an incredible diversity of life, until the next mass extinction. This is the first episode of a 6-part series on mass extinctions. Make sure to follow the Colossal YouTube channel for the next episode, where we're gonna go over the confusing mess of the Devonian mass extinction. See ya!